Hello and welcome to E233. I'm your instructor, Gregory Myers. In this video, we're going to take another look at file I/O, specifically how to read a file that contains pairs of values, specifically pairs of doubles that correlate ultimately to X and Y coordinates. This video is part of a larger series of videos focusing on file I/O, such as the ability to read, append, and write to files. So to begin with, what you want to do is obtain a copy of our read_demo_03, as well as our input_04.csv. Before we go too far into this, you want to take just a second to look at the CSV file and note that it essentially is pairs of values, each on a row, and what you will discover is that they correspond to the X and Y values of the function y equals to 1 minus x squared from an x min of 0 to an x max of 1. So basically what this is 101 values that represent the x from 0 to 1 and the corresponding y values. You can take this file and plot it in Excel, for instance, so that you can see the overall shape of the function. The other thing that you'll want to go ahead and take a second to note is that I provided you a little bit of background, specifically in a form of a Wikipedia article that looks at numerical integration and the idea of summing the area then under a curve to be able to estimate the value of the integral. And to understand a little bit better about what we're going to try to do in this example, you'll want to take a look at the Wikipedia article. Specifically, what you want to do is look at the rectangle rule. And you have both this example and also I'll provide you with a PDF that demonstrates a little bit more of what we're trying to do here in our numerical integration. And so here, once again, is our line for y equals to 1 minus x squared. And essentially what I'm doing here is I'm breaking this up into a series, in this case, of 10 rectangles. Each of the rectangles use the leftmost value to be able to calculate the height of the rectangle. And the width of the rectangle is simply the value or the difference in values between corresponding x values or neighboring x values to be able to calculate then the area of each of these smaller rectangles. And then we ultimately sum up the area of, in this case, these 10 smaller rectangles to get an approximation of the value for the integral. And in this case, I've also went ahead and shown you how we would do this by hand. In this case, from 0 to 1 of 1 minus x squared then simply corresponds to the value 2/3. So what I'd like for you to do is sort of keep this in the back of your mind and also the explanation in the Wikipedia article. And what we want to do in this video is we want to focus on how we're going to do this in C. So to begin with, we'll go ahead and copy over our function prototypes, as well as the beginning of our function. Notice that our function does not accept any input arguments or return any output arguments. This function is relatively self-contained, so we will be hard coding our file names. At this point, you can go ahead and close your snips file. And what we'd like to do is we'd like to update our help and our command line switches, or our if statement for our command line switches. And specifically, we'll add this up here along with our other read demos. And so this will be our read demo 3, which is going to call our read demo 3. And then likewise in our help, and we can simply copy and paste that. And what I'd like to do is make a little note here that this shows us how to read a file with doubles. And this is the numerical integration. And this is, once again, sort of an introduction to this topic. We'll cover it in future videos as well. So at this point then our switches are updated, our help is updated. Let's go ahead and build it to make sure that we do have a working executable. And now let's jump into the logic in our demo function, our read demo underscore 03. So to begin with, there are going to be a couple of things that are going to be in common with our earlier examples. And that is that we simply want to go ahead and create a input file pointer. And then what we want to do is we want to remember that we want to keep track of the total number of areas that we have, or the total area. There's a couple of different ways that we can go about doing this. At the very least, though, we will need a variable that will ultimately have the total area. We also want to have some temporary variables that will allow for us to capture the X and Y values, but not only the X and Y values for the left side of the rectangle, but also for the right side of the rectangle. And what I mean by this is we'll take a look at my simplified drawing here. Essentially what we're going to do is we're going to read in a pair of values, an X value and then a Y value for a single point on the x-axis. So in other words, this will represent one line in our file rather. And then we're going to also read in the next value for the X and the Y values, or the next line, with the idea being is this left side will represent our X1 or our X left, and the second line will represent our X2 or our X right. This will allow for us then to be able to get our delta X, or the difference between the two X values, in order to calculate the width of our rectangle. We're essentially going to be throwing away, at least for the purposes of calculating the first rectangle, our Y2. However, though, if you notice that what we're going to do now is we're going to then use the second X and Y values as the beginning point for our next rectangle, for our second rectangle. So essentially what we're going to be doing is we're going to be reading through the file line by line to get the X and Y pairs that we will need to be able to calculate the area of each one of these rectangles. So in order to be able to do this, we actually are going to need two sets of X and Y values. So we're going to start off, we're going to call this one X1. We're going to also have a Y1. If you like the idea of an X left and an X right, that's also perfectly fine. But in this case, I'm going to have a X2 and a Y2. At this point, we might find ourselves needing some other temporary variables, but this is at least a good start since we don't have any return value. And essentially all we're trying to do is calculate the area by looping through all of the rows in this file. Keep in mind that this is a demonstration of opening a file with two columns of data separated by commas, and we're just sort of giving a purpose behind it by demonstrating numerical integration. So what we first want to do is use our input variable and our fopen to be able to open the input file. And in this case, it's going to be input_04.csv. And once again, we're going to hard code this. We could just as easily have accepted this as an input argument to our function, and we're going to open it for reading. At this point, the next step that we always want to do when opening a file is to check to see if the file input is in fact not equal to null. In other words, that we do not have a null file pointer. This happens when the name of the file is perhaps incorrectly entered, or for some reason that you don't have access to the file. Under the else branch, we simply want to go ahead and print out a message to the user that says error, failed to open input_04.csv. And at this point, we can follow this up with a new line. We can clean this up just a little bit, perhaps even capitalize the F, and so on. But under the true branch of the if statement, in other words, here, we want to do something with the data. And to begin with, what we want to do is we want to capture the first row using our fscanf. And then what we're going to do is we're simply going to check to make sure that we are, in fact, capturing it correctly, because this is the first time that we've had two values, and more specifically, two values separated by a comma. We're going to need to do a little bit of trial and error. And to begin with, what we're going to do is we're simply going to have an if statement that says if fscanf, and if you'll note here that we need to use our input file pointer, but then we also want to specify that we have two doubles, so %lf and %lf separated by a comma. Those two values then we want to have stored in our x1 and our y1 respectively. And then we, of course, want to make sure that that is not equal to end of file. In this scenario, if we're reading the first line out of a file and we end up getting an end of file, that means that there was no data in the file. So at this point, what we could do is we could simply follow this up with an else if, or an else rather, and simply say printf error, no data found in our input underscore 04.csv. Now, under this scenario where we did successfully retrieve a value out of the file, then what we'd like to do to begin with is simply print out those two values. And in this case, what I'm going to do is I'm going to just have a nice glorified print statement here. I'm going to say my x1 is equal to %.4f. I'm going to keep it limited to 4 decimal places for right now, because if you notice, that is the longest, the most number of decimal places or values after the decimal place, at least for the y value here. And then our y1 is going to be equal to %.4f, followed by a new line. And then in this case, what we want to do is provide our x1 and our y1. And so ideally what we'd like to do is verify that we can successfully read in one value before we attempt to read in more. The last thing that we want to do now is we also want to note where to correctly close the file. And note here that I'm going to close the file only after I have successfully opened it. In other words, I'm guaranteed that I have a non-null input file pointer. So at this point, then we're going to put our fclose inside the true branch of our if statement. At this point, we can go ahead and build it. We can come out to the console, clear the screen. We're going to check to make sure that our input underscore 04.csv is in our correct folder. So what we're going to do is we'll cd over to our files, demo, distribution, debug, min.gw, and you'll see there is no input underscore 04.csv. So what we can do is we can use Explorer in the current folder. We'll notice that once again, we do not have our input file yet. What we'd like to do is copy or make a copy of it and paste it then in the correct location. And at this point then, what we can do is we can simply run our files demo.exe. We can put a /? or /h, and you'll see that we have our help. And at this point, what we want to do is run our read demo underscore 03, and you'll see that we have in fact been successful at pulling out the first two values in the file. So what we'd like to do then is just take a second to make sure that we understand that we are reading in two values out of the file, and we are utilizing this first format specifier to decide what value goes into our first variable. And we use the second %lf to then decide what value goes into our y1 variable. At this point, you'll want to take a second to once again look at our sketch here. And the idea is that we want to use this value, this x1 and y1, to be able to calculate then the height of the rectangle. And so notice here that my x-axis value here is going to be y equals to 0, and then my y1 represents the height of the rectangle because the fact that we have essentially y1 minus 0. My x1 is going to be used in conjunction with my x2, which means that we have to read another line out of our file. And so what we're going to do here is we're going to come back. We're now going to set up a while loop, and we are once again going to leverage our fscanf. We're going to use our input file pointer. We're going to use the same format spec that we just saw worked correctly. So there's our %lf, %lf. But this time around, we're going to put those values into our x2 and our y2. And once again, we just simply want to make sure that that does not, in fact, return end of file. Now, at this point, it might be useful for us to create two more temporary variables just so that we can understand what's going on. And you can call these x delta and y delta, or you can also call them just simply width and height, whichever one makes the most sense to you. I'm going to use x delta and y delta because we're going to use these in later videos as well. And so the idea here is that inside of our while loop, we're simply going to use our x2 and our x1 to be able to determine then our x delta, which is essentially the width of a segment or the width of the individual rectangle that we are going to attempt to calculate the area for. We can do the same thing now with the y delta, but we do not in fact use the y2 and the y1. Instead, what we do is we simply leverage the y1, and I am going to explicitly state that we are going to be subtracting 0 here because essentially this is going to be the height or the difference from the x-axis. Now, at this point, the area calculation should be pretty straightforward because essentially it's just going to be the width times the height, but we also want to leverage the sum here. So the idea is that as our while loop iterates, we simply want to keep summing the area. In order to accomplish this correctly, we want to go ahead and initialize our area equal to 0. And inside of our while loop, we simply take the current value of the area and we add to it the x delta times our y delta. Now, we're almost done. What we have to do is as we iterate through the contents of our file, remember that we said that as we move through our function or through our rectangles, essentially this becomes the new left side. In other words, this value right here, you probably need to look very closely at the PDF file to see here that the old y2 becomes the new y1, meaning that in order to calculate the height of the second rectangle, you actually use the second line in the file. Likewise, to calculate the height of the third rectangle, you use the third line in the file. To accomplish this, what we're going to do is we're actually going to assign to our x1 the value of x2, and to our y1 we're going to assign the value y2. And then this will allow or free up our x2 and y2 to be used by the next iteration of the while loop that is simply going to grab another pair of values out of the file and store them at the location of x2 and y2. And this process simply repeats until you run out of lines in the file. The only other thing that we'd like to point out briefly is the fact that this file has 101 lines in it. But if you'll notice that effectively in a rectangle, when we're using rectangles to calculate the area of a function, or in this case, the area under a curve that is represented by some data points, that we essentially have one less rectangles than we do data points. So for this simple drawing here, notice that I have a total of 11 data points, but I only have 10 rectangles. This is true also in our file, that we have 101 lines, but we will in fact only be able to calculate 100 areas. And to prove that to ourselves, what we want to do is we want to create one more temporary variable. In this case, we're going to call this index. We're going to initialize our index to 0, and every time we make an area calculation, we are simply going to increment the index. You could also have simply called this count. Doesn't really matter. In future examples, we'll actually leverage this index variable. So at this point, what I would like to do is I would like to, outside of the while loop, print out a nice little table, once again with a name and a value, followed by a new line. And we'll make this table fairly small because there's only going to be a couple of values in it. We'll have our nice border once again, same recipe that we've used in multiple videos. And then what I'd like to do here is simply specify the count or the index. And this is going to be a %d. And we'll follow that up with a new line. And I tell you what, we are going to go ahead, just for clarification's sake, we'll go ahead and change our variable name here. And this is going to be the count of the number of rectangles. And then once again, we just simply want to increment our count. Once again, the variable name doesn't really matter. It's the concept more than anything. This will show us how many rectangles we've actually calculated. And then we want then, of course, the magic value here, the area. And this is going to be a %.4f followed by a new line. And then we simply want to put in the area. Now, once again, I've accidentally capitalized our area here. Let's take just a second to keep consistent. So I'm going to change then my area to lowercase. Should have hopefully made all of the changes. And at this point, then we should be ready. So we'll go ahead and build this one more time. You'll see that we have a build successful. And at this point, what we can do is we can come over to our command line. We'll rerun our read demo, and you'll see that I'm getting an area of 0.6717. And if you'll recall from the PowerPoint slide, we should have gotten 2/3, which means that we are slightly high. Well, that makes sense if you take a look at these red rectangles. they essentially encompass a larger area than the function does. In this case, our function is y equals to 1 minus x squared. But as I increase the number of rectangles, we would expect that error to be getting smaller and smaller and smaller. So what I would encourage you to do is sort of play around with this a little bit to make sure that you understand how this is done. Perhaps use a tool like MATLAB. But for our purposes right here, you'll see that we have, in fact, 100 rectangles, and we have calculated an area of 0.6717. So at this point, we can just spend a little bit of time cleaning up. I'm actually going to move my values over just a little bit to make my table look a little bit better. You can also consider printing out our X values as we collect them from the file. So in other words, what we can do here is we can simply have another printf inside of our while loop that simply shows us capturing the values line by line. That's perfectly fine. So in this case, what we'll do here is we will have a printf that has, for instance, a x2 equal to, actually, let's go ahead and do all four values here. We're going to have x1 equal to %LF or %.4F. Our y1 equal to %.4F. Our x2 equal to %.4F. And our y2 equal to %.4F, followed by a new line. And then what we'll do here is we will simply print out all four of our values, our x1, our y1, our x2, and our y2. At this point, we can go ahead and turn off this earlier printf, and we should get a nice output then that will help us track the data as it's coming in from the file. So you'll see here, you can see then how we are reading in the first set of values and then reading in the second set of values. There's our 0.01 and our 0.999. And then for the second iterations, then that second row becomes our first set of values, and the third row becomes our second set of values, and so on, all the way through to the last row. You'll notice here that our last set of values for our last rectangle are going to be 0.9900 for the left side and 0.0199, in other words, the 100th value in the file. And then our right side is going to be 1 and 0. So hopefully this was a nice introduction, not only to numerical integration, but also helps you understand how you can read multiple values from a file at a time. In other words, using a single fscanf. As always, if you have any questions or comments, don't hesitate to email me, and thank you for watching.